Hey there, 8th graders and Eli. We're going to be doing rational expressions today and working with them, factoring them, zeroing them out, simplifying them, and such. Okay, so we'll show you how to do all those things. But just first of all, what is a rational expression? It's an algebra fraction or algebraic fraction. And in the numerator and denominator, you have some polynomials. You have some chunks of numbers and variables, okay, kind of like this. And so we're going to be working with some of those fractions today. The first thing they're going to want us to do is find the excluded values. In other words, what you can have for the variable in the denominator. Since you can't divide by 0, there are certain numbers you cannot have, right? So what you're going to have to do on these is factor the bottom and then solve for 0 once you do. Now you'll probably notice this is a difference of squares. This goes back a little ways, but do you remember a difference of squares? Right, a difference of squares always factors like this, right? When you have something squared minus something else that you can square root, it's always the plus and the minus pair, right? So notice our two excluded values, if we put both of those equaling 0, right, and then solve, we'd get -6 and 6. So our two excluded values for this one are 6 and -6. R could not be either of those, or it would not work. You can't divide by 0. How about with this one? What are the excluded values? So again, we're going to factor the denominator and find out what values we cannot put there that would make that equal 0. So notice this is a simple one where we think, okay, what two numbers times each other equal this? That would add up to this, right? So I'm thinking n plus 5 and n minus 1, right, would add up to that. And so those are our two solutions. And so we put those both equaling 0, and then we solve, right? So we end up with -5 and +1 as our two solutions that it could not be. Hopefully that's making sense. One more. Notice again, difference of squares. Okay, so we can think, okay, these pairs are x plus 9 and x minus 9. So our two excluded numbers will be 9 and -9. We can't have x equal those. Those need to be excluded. Here's one more where we have to factor, right? So if I think factoring this, let's see, a plus 4 and a plus 2, right, would give us a pair that would add up to 6. And so then our two, if we would solve those both for 0, we realize that -4, if we would solve that for a, right, and -2 are our two excluded values for that one. So that's how you do that first section today. Then they're going to have you simplify rational expressions, okay? And the way to do that is you're going to first factor anything that you can factor. So for instance, let's factor both this numerator and denominator. Notice in the numerator we can divide out 2, right? So we're going to do that right away. And so that would leave us with r plus 9, right? And in the denominator we can factor that 2. We can think of two numbers that equal -9 that would add up to 8. So how about +9 and -1, right? So that would be our two pairs, r plus 9, r minus 1. And then notice we have some things that we can cancel out, right? Because if you divide something by itself, it just equals 1. This cancels out. And so all that we're left with is 2 over r minus 1. Notice we're only half done, though. So we've simplified it. That was the first step. And then we need to state the excluded values. So to do that, just look back to what you factored out in the denominator, right? This was our denominator. And just put those two things equaling 0 and then solve, right? So we'd get -9 and +1 would be our excluded values. Okay, so here's our simplified part of our answer. Here's our excluded values part of our answer. Let's do another one just so you can see these quick how they go. Again, let's factor both the numerator and denominator if we can. Can't do anything with the numerator this time. Definitely can factor this though. So let's do that. So I'm going to just put my numerator here and let's factor this. Let's see, 21. How about 7 and 3, right? So n plus 3, n plus 7. And you're going to notice right away we can factor that out. So we're left with 1 over n plus 7. And then to get our two excluded values, remember what we do? We just look back to what we factored out in the denominator. Put those two pieces equaling 0. And then solving for n, which would be -3 and -7. So those are our two excluded factors. So there's our two answers. We simplified it. We found the two excluded factors that we cannot use in the denominator. I just want to point out in this next one, notice we can definitely factor the top here. That would be y plus, let's see, y plus 10 and y minus 1, right? That would give us that 9. And then notice on the bottom, you can factor out a 2 here, right? So you get 2 and then y plus 10. And then notice once again we have a pair, so we end up with y minus 1 over 2, right? And then notice what we factored out in the base. We can ignore this 2, but we factored this out, right? So if I put y plus 10 equaling 0, then the one excluded value is going to be negative 10. That one only has one excluded value. Don't have to worry about this number that you pull out. Just work with the factored out pair. Okay, I want to point out something strange that can happen that your book points out too. Let's factor these two. And I want to show you something strange that's going to happen on this one. Okay, notice this is a difference of squares, right? So in other words, the pairs can be the opposites, right? You got a plus and a minus pair. And so this would be 6 minus t and 6 plus t, right? Would equal that, okay? And on the bottom here, notice we can divide out a 5, and that leaves us with t minus 6. Now, I don't see anything I can divide out unless you think of it like this. Do you see how these two pairs are really opposites? So that top one, I could rewrite like this. I could take it times negative 1, and then notice if I took it times negative 1, that would give me negative 1 t minus 6. Negative 1 times t minus 6 is the same thing as this, right? Do you see why? Because if I took negative 1 times t, I'd get my negative t, and negative 1 times negative 6, I'd get positive 6, right? So to make this one, this top one, match that bottom one because they were opposites of each other, I rewrote it like this. See how that works? So let's rewrite the whole thing. So I got negative 1, t minus 6 on top, 6 plus t, okay? And then on the bottom, 5, t minus 6. And now we can definitely divide some stuff out, can't we? We can divide out these chunks now that they look the same, right? And that all that leaves us with is negative 1 over 5, 6 plus t. Okay, and now we have to state the excluded factors. Notice if I go back to my denominator, t minus 6 is the only one I have to work with, so my excluded value is going to be 6. So here's my simplified one, here's my excluded value, my two answers. So that might happen from time to time today. If you end up with opposites like these, take the top one or one of the two times negative 1 and rewrite it so that it matches then, and then you can cross them out. Okay, the last type of problem then, you're going to be asked to find the zeros. The way you do that is you replace f of x with 0, right? And then you factor the pieces. So let's factor this first piece. Let's see, 6 and 3, right? So x plus 6 and x minus 3 would give us what we need for that pair, right? Okay, and then this bottom is x minus 3. And then notice what happens. These cancel each other out. So you end up with just 0 equals x plus 6. So what's your solution for x? What's your 0? Solve by canceling that out, right? And you get this. So there's our 0. That's an example of one that has one solution. Let's look at one that has two solutions. Okay, this one they want us to find the 0. This one's going to have two solutions. That can happen too. So let's replace the f of x with 0. Let's factor this one. Let's see, negative 3 and 5 should give us that negative 15 and then add up to 2, right? And this is x plus 1 here. Now remember, if our numerator equals 0, then our solution will be 0, right? Because anything 0 divided by anything is just 0, right? So let's make our numerator equals 0, right? And so in other words, if either of these equaled 0, I'd have a solution of 0. So let's just set these up equaling 0 and then solve, right? So x equals positive 3 or x equals negative 5, right? So those are my two zeros. So that's how you solve that one. Now, anytime you have if you're wanting to find the zeros, just make the top 0 or solve, factor it and then solve for 0, and you'll know. Because 0 divided by anything will always be 0. So that's one of your zeros or two of your zeros in this case. All right, let's get you going on your assignment with a few quick problems, and then I'll let you do the rest on your own. So this one, we just have to state the excluded values. Notice we have a difference of squares down here, right? Our denominator can't be 0, so we could find a difference of squares here, right, on the bottom. And we realize that if we put both of those equaling 0 and solve for x, we'd get 4 and negative 4, right? So there's our two excluded values for number 1. I want to look at number 3. It's a little bit complicated sounding, but it's not really as hard as you think. They give you this little rational expression, okay, and then they give you what all the letters stand for. It says a 0.16 kilogram ball, so that's the mass, right? So I'm going to put that where the m is, 0.16 kilogram ball, is attached to a spring is being spun in a circle at 7.26 meters per second. So that's the velocity, right? That's how fast it's moving or spinning. So we're going to put that where the v is squared, right? Okay, and then it tells us the radius, I believe. If the circle has a radius of 0.5 meters, yep. And so all you're going to need to do really is do the math on this one. So if we take 0.16, I got my calculator here by me. I'll tell you what, let's square that first part. 7.26 squared is about 52.7. Okay, for that. And then if we take that times 0.16, we end up with about 8.433. And then we're going to divide that by 0.5. So really it's just a substitution problem, and we end up with about 16.9 units of force. That's what it's asking about for that one. So I just wanted to point that out, that one's not as complicated as it sounds. The first time I read it too, I was like, whoa, that's a lot to think about. But it really is just to substitute the pieces in and solve problem, okay? Okay, then in the middle section, you'll be simplifying and stating the excluded values. Don't forget both parts of this one. So notice this one is one where we can just divide both of the pieces by something, right? Notice both the top and the bottom can be divided by 4, right? So let's do that. So this would become 7, and this would become 4, right? Both of them have at least one a in it, so let's divide out an a. So there's no a left on the top, only an a left on the bottom, right? And then both of them have at least one b. There's two b's left on the top, and we divided out the b on the bottom. So we have just simplified it. Some are as simple as that, just dividing out similar pieces, right? Now we have to state the excluded value. So what could a not be? A cannot be something that would make our denominator 0, right? So in other words, the only possibility that a could not be, put a slash through your equal sign to show your excluded value, would be 0, okay? And so there we go. That's both parts for number 4. Number 6, this would be one where we're going to factor to simplify, and then we'll do this, and we'll state the excluded value. So let's do that. Notice on the top, we can divide out 5, can't we? So we end up with 5d plus 3, okay? And then let's factor that bottom for 12. What if we went with negative 4 and positive 3? That would give us this minus 1 that we would need in the middle, right? So if I put those right here, now we can definitely cancel something out, right? Let's do that. So we end up with this, 5 over d minus 4. Then I want to know the excluded values. Remember, you go back to your original denominator here when you factored, and these are your two excluded values. Just put them both equaling 0. And then solve, right? So this would be 4. This would be negative 3. So you would say d cannot be 4 or negative 3. So there's our two solutions for that one. All right, here's one like the very last section on the first page. Okay, they want us to find the 0, so we're going to replace f of x with 0. And then let's factor out these pieces. Okay, notice this top one we can do x minus 3 and x plus 2, right? That would give us negative 6 and negative 1. And on the bottom we can factor out, let's see, x plus 6 and x plus 2 should work, right? To give us 8. This is a 12, by the way. There we go. Okay, then we can cancel out these pieces. So we end up with x minus 3 over x plus 6. Now remember, when we're trying to find the zeros, we want to change our numerator into 0, because anything 0 divided by anything, right, will always equal 0. So what would I put in for x to make us have a 0 on top? 3, right? So x equals 3 would be one of the zeros. So for the find the zeros one, think about making your numerator 0, right? When you're doing the excluded values one, you want to find out what options would make the denominator 0. So be careful not to flip-flop those. When you're finding the zeros, try to change your numerator into a 0. Or sometimes everything cancels out except for like 1x plus 3, then it's easy to solve. But if not, like if we end up with something like we did here, just make your denominator 0. How would we do that? X equals 3 would make that 0. So that's going to be for sure one of our zeros. Hopefully that makes some sense and that gets you off to a good start. I know this is new. I don't think you'll find it overly hard. It's a lot of stuff like factoring that we've done in past chapters. But don't be afraid to reach out if something doesn't make sense. Have a good day, guys.